Thanks, Bridget. Good morning, everybody. And it's so exciting to see how everybody's coming into the room at the moment. So I think that definitely we've got a nice topic that is very interesting and intriguing, and obviously sparked quite an interest. So of course, welcome to COSCEM members, COSCEM visitors for today. And then I would like to welcome Donovan Perrins. Donovan, am I pronouncing your surname correctly?
You are correct. Yes, indeed.
Perfect. Great. So Donovan is a dedicated researcher in the field of cognitive neurosciences. And from stalking you on LinkedIn last night, Donovan, it looks like you're quite passionate in unraveling the complexities of the human brain. So today we are very interested, and we look forward to the session where you will then unpack our brain and how it links with beauty. So we look forward, and I hand over to you.
Thank you so much, Marcel. I really do appreciate it. It is a passion of mine. I'm not going to lie. I find it very fascinating. At one stage, I will even admit that I did see people as brains on sticks, because it was such a fascinating way to kind of look at people's behavior in that regard. But yes, thank you so much for such a nice introduction. I really do appreciate it. I am Donovan. I am a neurobiologist, essentially. And in terms of my research speciality, it's usually regarding drugs that are related to like neurodegenerative diseases. So honestly, when it comes to something like the interesting connection between, the skin and the brain, it's something I'm really excited about, because it blends two worlds, cosmetic science and neurobiology. And when we're thinking of it, and we're thinking of neuroactive skincare, I'd like you, for the entirety of the presentation, to kind of keep this in your mind. What if skincare could speak the same language as your nervous system? Now, this is a bit of a minefield, admittedly, because it is such an emerging field. We have a lot of people who define very interesting ideas of what specifically a neuroactive is. And I think that it would be a good idea just to start with a basic definition. When we're thinking of a neuroactive, or when we're thinking of neuroactive skincare, it's a field that treats the skin not just as a barrier. It's something that recognizes the skin as a sensory organ, and one that actively communicates with your nervous system. Now, where that is really quite interesting is in science, particularly neuroscience, we have a very bad habit of siloing. We often don't think of any of the other interesting systems and how they interact. So it's really quite an amazing field at the moment. Now, if it sounds futuristic, look, I'm not going to lie, it is. But it is also real, it is measurable, and without a lot of people knowing, it's already showing up in a lot of product lines. So over the next hour, what I'm going to do is I'm going to walk you through what it is, how it works, why it matters, and then obviously where it's going. I do have to say, because it is only an hour, I am presupposing quite a great deal of knowledge. Thank goodness for a question and answer section at the end. I could not go in as depth as I wanted to, because there's just too much information, so to speak. So I suppose, as I said, a good place to start would be the definition. So when we're looking at neuroactive skincare, it is the use of ingredients that interact with the skin's nervous system. Particularly for the field of cosmetics, we're very interested in actives that calm sensory irritation, reduce inflammation, or even influence how the skin feels. And I say this quite tenuously, perhaps even emotionally. So the psychological aspect does come in quite a lot. And what's important though is we are not talking about numbing creams. We're not talking about exogenous moisture. We're not talking about that. We're talking about smart, targeted communication within the skin's natural signaling systems. So imagine that you're writing a message to your skin in a language that it does already understand. Now, when we are looking at our skin's neural network in particular, we do also have to understand that our skin is not just protective, it is also perceptive. It has pain receptors, it has temperature sensors, it has chemical detectors. I'm not going to go into them, don't worry. But all of those nerve endings talk to the brain and even immune cells constantly. So when we're looking at it, we have to realize that the skin itself, in its cells, produces neurotransmitters. Substance P, CGRP, don't worry, the acronyms are just acronyms. I will answer the questions at the end. They influence inflammation, sensitivity, they influence your mood. So when your skin flares up and you are stressed or tired, for once, it's not in your head. It is actually a neural response. So, if we are looking in particular at mechanisms of action, I'd like us to just dig into how it works. So, we can assume that neuroactive skincare mostly works through these three pathways. We have our first, which is receptor targeting. We have our second, which is neurotransmitter modulation. And then we also have our third, which I find the most interesting, neuroimmune crosstalk. When we are looking at the idea of something like receptor targeting, we have to understand that certain ingredients interact with receptors, like our TRPV1 receptor. A TRPV1 receptor is just a type of calcium channel that controls pain and mediated responses like that. So when we're looking at that receptor, it's responsible for particularly burning and stinging sensations in the skin. Now, what we have discovered is that if we repeatedly expose these receptors to a specific chemical or a specific compound, what we can do is desensitize it. And now, when we are desensitizing things in particular, we teach the skin to react in a more calm way. And we also teach the skin not to overreact. I mean, if we're thinking of it, a good example, the first time you try spicy food, oh my God, it's the worst. It burns. The second time you try it, it burns, but not as much. And eventually you develop quite a taste for it. Now, this comes in when we're thinking of neurotransmitter modulation. So we have the idea of something called substance P. Very, very creative name. Oh my God. Substance P is just a substance that is produced when your body is in pain. Now, some of our actives reduce substances like substance P. So we reduce inflammation, we reduce itch, or we boost endorphins. We help the skin feel soothed. And that's what is really, really quite important. When we're looking at it, we're not talking about a generalized release of neurotransmitters like when you exercise, oh my God, we have endorphins going through our body. We are more talking about a localized response. Okay. Now, as I said, for me personally, neuroimmune crosstalk is probably the most interesting because this is where our neurons and our immune cells sort of influence each other. So what we've done by manipulating, or rather calming this loop, we reduce chronic inflammation. Things like rosacea, stress-induced redness, all of those things can be ameliorated through this. Now, that is obviously just mechanism of action for the three that I find the most interesting. There are many, many more, but a lot of them kind of branch into pharmaceutical use as opposed to cosmetic use. Were we to look now at our key receptors, here is where it starts to get particularly interesting for me. We have our receptors, as you can see on the screen, TRPV1. We have our mu-opioid receptors. We have our acetylcholinergic receptors. And then we have, I suppose, the most commonly one, our cannabinoid receptors, CB1 and CB2. The functions of each are essentially different, but they all share a common thread. Now, if I could give you an analogy, particularly when we're looking at our TRPV1 receptors, it is essentially your skin's smoke detector. It senses heat, it senses pain, it senses acid, changes in pH. And when we have particularly sensitive skin, it's like a smoke detector that goes off when you're making toast. Not something that we would obviously like. So neuroactives teach that specific receptor to calm down, not to overreact. When we're looking at our mu-opioid receptors, these particularly respond exceptionally well to endorphins. When our mu-opioid receptors are triggered, they reduce itch and they improve a feeling of comfort. So when we're looking at that, we have to acknowledge that some of our peptides act as precursors, which encourage our own skins to create those endorphins. Nicotinic acetylcholinergic receptors, they are, again, something quite intriguing because they are specifically geared towards wound repair. They are specifically geared towards cellular communication. So if we imagine them, I suppose a good example would be an intercom system in a building. They are the coordination of our neural pathways. So when they are supported, your skin coordinates a lot better, whether it be healing, whether it be barrier repair, whether it just be calming down. And then, as I said, the receptors that I think most people are most commonly aware of would be our cannabinoid receptors. They respond to our cannabinoids and similar compounds. It's very, very interesting a field to research, particularly when we're looking at reduction of inflammation. But in this field, it is also important to note that a lot depends on perception. So when we're looking even at clinical trials, when we're thinking of the way that it makes us feel, it's an important thing to sort of remember. Now, if we are thinking of how these things work together, essentially, as mentioned earlier, either we are going to overstimulate, we are going to stop stimulation, or we are going to train them to react within a certain parameter. Okay. When we are looking at a lot of the interesting chemistry, I suppose, or at least a lot of the chemistry behind the actives, it's not just about fancy names. Now, I chose 5 simply because there were too many, and these were the most interesting. Again, we have obviously our palmitoyl oligonucleotide. It's a small peptide chain. It has a fatty tail, and it is that tail that helps it slip into skin layers where it reduces inflammation as well as stimulating collagen production. Matrixyl is another palmitoyl, but it is a palmitoyl pentapeptide where it boosts collagen as well as indirectly supporting endorphin pathways. So here we can see that a lot of our active work on more than one at a time. Acetyl tetrapeptide 2, it works to reduce substance P particular. So it is perfect for reducing, calming, and getting rid of that kind of itchy, reactive skin feeling. Cannabinoids binds to receptors that cool inflammation, they reduce oxidative stress. And then your POMC-derived peptides convert directly into beta endorphins in the skin. So if we imagine our POMC-derived peptide as your skin's natural chill pill, for lack of a better word, when we are seeing these being used in particular, as I mentioned a little bit earlier, a lot of them are used in conjunction, right? And particularly when we're looking at our palmitoyl oligonucleotide, we're looking at our acetyl tetrapeptide, those would be probably the most interesting in terms of cosmetics. But how do we actually get these actives into the skin? It is one of the big problems, particularly when we're looking at peptides. Peptides decay incredibly fast. There's no point in having an expensive ingredient if it doesn't stay active on your skin long enough to penetrate. So when we're looking at a formulation in particular, what it is, oh dear, what it is specifically active ingredients, carrier systems, and our enhancers. All right. Now, our active ingredients are obviously the fact that it's fragile. They're expensive. A lot of them are hella unstable. It's not something that we can just apply to the skin. Now, a lot of formulators will use things in particular when we are looking at liposomes and nanocarriers. So a liposome, as I'm sure a lot of people are aware, would be a tiny fat-based sphere that carries the peptide through the dermis. Now, obviously, when we're looking at this, we also have penetration enhancers, which are also similar to short-chain fatty acids, where they temporarily soften the skin's barrier, allowing for more permeation into the skin itself. But where it really comes into play is a smart combination. So when we are looking at particularly a neuropeptide, were we to combine it with something like a ceramide or an antioxidant, what it will do is form a layer over the skin, protecting the skin while still delivering the message into the skin. Beyond that, a lot of the problems that we face will be stable pH. Neuropeptides are very, very sensitive to pH changes. We would have to probably add chelating agents. We would have to add smart emulsifiers. All of these things are used in order to keep everything active until it is delivered. Now, where I find this to be particularly interesting is many a time when you are talking about this, people have very, very strange ideas about what it is. In fact, I believe once I encountered the fact that because the product tinted your skin, it made you feel good, ipso facto, it was a neuropeptide. That unfortunately doesn't suit the definition. Psychological definition, perhaps, yes. But when we're looking at this in particular, we have to be aware of the fact that they must have an impact. So kind of getting it into the skin is the biggest problem. We have so many different neuropeptides at the moment that have so much potential. However, they're too unstable. And because they are too unstable, we spend more time formulating, and it is quite the frustrating process because things that happen in the lab are not always things that happen in real life. But when we are thinking of the clinical evidence, I'm not going to go into this, don't worry, we're not going to go through 3 different case studies, but the evidence shows that it works. So if we are looking at our first study here, it is a study that literally just added palmitoyl oligonucleotide to people who had had microneedling, who had had very, very reactive skin. And This Gavante et al. Had 40 subjects over 4 weeks. Every single subject showed a reduction in skin reactivity by 26%. They showed a reduction in transepidermal water loss by 18%. Now, if we're looking at all of these studies, if you would like to go through them, there has literally been a report of over 20% for most things. So it's an important and it's a very, very beautiful field to look at in that regard. So when we are thinking of this, it's not just a cosmetic improvement. Because of these subjective improvements over the 8-week studies, like decreased stinging, better skin comfort, it is a meaningful change on how the skin is responding to environmental stresses. And because of that, it's something that is really, really intriguing to me. So, another thing to be aware of, particularly when we're looking at clinical evidence, is just to be aware that a lot of the clinical evidence that we are currently getting also has a large part to do with perception of the product. I'm sure everybody has been really warm and sprayed cold water on their face. Wow, we feel refreshed. That feeling or that psychological wellness is really, really quite important because if you feel soothed and calm, whether it's placebo, whether it's not placebo, you will receive a real result because that feeling translates into active, real results. A lot of brands that we are looking at now, they really, really do apply this. I'm hesitant to mention names, but if we're looking at SkinCeuticals uses a neuropeptide blend in all of their calming formulas. Clinique even has a reference to the skin's internal repair language. Neurogan, it leans into cannabinoid pathways. All of these things are really, really intriguing from a scientific perspective because it means that we are treating the skin differently. And as I said, the thing that I would like you to please keep in mind throughout this is we are speaking the same language as our nervous system. So we're not just soothing, we're sending messages. We're not treating the surface, we're communicating with the skin. And it's a very intriguing thing to think of. What happens when we do start talking to the skin? For me, what I really, really am enjoying a lot is how the market has changed. So when we're looking at our market landscape, we have to understand it's not niche any longer. The market for neuroscience-based skincare is projected to hit over $3 billion by 2030. And this is because we are moving into the age where consumers want personalization. As much as we are facing quite a large anti-science rhetoric, people want smarter science. They want a holistic approach to things, which is something that these neuropeptides, they do offer. So the space itself is attracting biotech startups. We have, as I said, our cosmetic giants, which are jumping into it, but it's also being brought in by mental wellness brands. So it's not so much just about the skin, but it's more about how you feel and how you feel about your skin. What I also think is really, really intriguing is the fact that it's quite hush hush. Not very many people are hyper aware of it. We're seeing a lot of branding lines, we're seeing a lot of marketing lines being used. And what they are just insinuating is the fact that we are using neuroskin or emotional skincare. I have to admit, I hate emotional skincare. It is not something that I personally would define because it's a very slippery slope. But these kind of things are being used to build a story whereby our neuropeptides or our neuromodulators, at least, are honestly seen as the heroes, so to speak. When we look at this, though, an important thing to obviously remember would be our ethics. Now, as mentioned earlier, um, we can't say that because a product tints your skin, it is a neuromodulator. We can't say that because a product makes you feel a certain way or influences your mood, don't ever say that, it is a neuromodulator. So we have to look at a lot of the regulations. These products aren't drugs. We have to be very, very careful about our claims. Further to emotional skincare, you can't say a cream treats depression yet, or that it blocks pain receptors yet, mainly because that crosses into pharmaceutical territory. Um, I'm sure within the next 10 years, if we are looking at it, we will soon have creams that do indeed treat depression. We will have creams that do block pain receptors. But for the purpose of this, something that we should rather talk about would be things that add comfort. They soothe, they balance, they add resilience. Okay. These are all terms that are backed by data and they don't have the false promises that a lot of new unregulated products might necessarily have. I have to admit, it is very intriguing to think about it because if we split it and we think of a localized versus a generalized reaction, technically, if we are introducing or if we are impacting our beta endorphins, we are impacting our mood, but it becomes quite a slippery slope because, well, the thing about neuroscience is that we're working in the dark a lot. So we're not 100% sure of how these mechanisms work. And it would be quite foolish to make these grandiose claims, particularly because it just opens up a world of trouble. The problem with that, obviously, is that science is still catching up. We don't fully understand it. I will admit it. I hate to admit it, but I will admit it. We don't even understand how our own nervous system works, never mind the skin's nervous system. We don't know what the long-term effects of modulating it will be. However, seeing as it's science, I feel like that is not necessarily the worst thing. That is how we obviously make progress. A lot of the problems that we face, particularly here, is the lack of funding, cost barriers. Gosh, they are the worst. Because of cost barriers, we can't always research the things that we'd like to research. We are obviously given what to research, and I feel like that personally is quite a frustrating part. Maybe I think too much of myself. Maybe that's the problem. I don't think so. But for me, the complexity of it is honestly just the fact that we have to find funding for things that might possibly not work because of degradation, or they don't penetrate well, or they work in the lab, but they don't work in reality. So while it is a very, very exciting territory, we really do need to apply ourselves a little bit more. We need more rigorous studies. We need a lot of transparency because Without those studies, unfortunately, we will not obviously increase our understanding of it, and we will not be able to presuppose or predict what might happen if we are consistently doing this. When we are looking here, especially at the future of things, this is where it is really, really amazing, because we are heading into an era where skincare adapts. I'm not talking about AI giving us a personalized blend. I'm not talking about having our skin, I suppose, audited and then being told what to do. I am talking about personalized skincare or personalized neuroblends based specifically on your skin's stress response as well as the microbiome profile. I mentioned the microbiome profile because it is something that has become quite a hot topic. We are using the skin's microbiome to communicate a lot with the skin because, well, in the past, it was not something that we thought of. It isn't something that even came to mind. But these kind of personalized neuroblends are something that I am honestly incredibly, incredibly fascinated by, simply because we have come to the realization everybody's skin is different. If we are looking at the application of vitamin C or ascorbic acid, some people can handle it, other people can't. We can't have a blanket term for everybody, which is, I suppose, the most interesting part about how the industry itself is changing. Another thing that I found quite intriguing were smart patches. Smart patches that react specifically to your skin. So your skin flushes red, the smart patch goes, oh my God, let me release this active. So this active gets released in real time. It stops flares. It's a really incredible thing, particularly for people who experience, well, neuroimmune responses, such as rosacea. It's a really, really beautiful field for them, and it holds a lot of promise. Now, what is happening is that there is currently a deeper focus on receptors like BDNF. Don't worry about it. It's just a different type of receptor, and purinergic signaling. When we are looking at this in particular, it is rooted in your body's communication system. And because of that, it's really quite a meaningful change in the industry. What is happening, though, is that whilst exciting, it's also terribly confusing, the future. So we are seeing the shift towards AI. We are seeing AI-powered personalization. Your skin's profile determines your neuroblend. Great. But for me, as I said, when we are looking specifically at receptors like BDNF or your purinergic receptors, it is a deeper targeting of growth factors. And that has the potential to change the way that we treat chronic inflammation as a whole. It has the potential to change the way that we treat skin aging as a whole. So I'd like us to sort of move away from the idea that this is a trend, because it's not a trend. It is sort of the beginning of a new age of skin health. And I feel like that is quite the important distinction to have because, well, skincare trends, as with most trends, are really, really quite fast and furious. So when we are changing the way we think about the skin, we're changing the way that we treat the condition, ipso facto, we're changing the way that the entire industry itself is working. So it's no longer fixing the surface. As I mentioned earlier, it's not just the addition of exogenous moisture. It's not just the use of a barrier cream. We're working with the skin's own language. And it's really an intriguing thought to think about how your skin talks. If I could, I would just like to go into a little bit more detail, particularly about two of the neuropeptides that I did mention. When we are looking at it essentially, especially as I said, acetyl tetrapeptide, because it inhibits substance P, so its use is in rosacea. I love it. I absolutely love it. It is honestly a groundbreaking sort of formulation because how do you tell your skin to stop being such a baby? How do you tell your skin to stop being so sensitive? Through this. So another thing to look at would be palmityl oligonucleotide. As I said, I'm a huge fan simply because it decreases your CGRP reactivity. So it reduces the amount of calcium that gets released and it increases collagen synthesis. So when we're looking at the idea of collagen synthesis, we're not just adding collagen to the skin. What we are doing is we are encouraging your skin to create it. We are acting on sirtuin pathways. We are genuinely changing the way that these pathways have worked through over quite a large amount of time. The important part about it, and perhaps I should go back because I got a little ahead of myself. I got very excited. Please excuse me. All of these receptors are found within your keratinocytes, except for your CB1 and CB2 receptors, but that's because, as I said, they regulate inflammation and it calms post-stress skin. But TRPV1, your mu-opioid, your acetylcholinergic receptors, they are all found in your keratinocytes. Some even found in your melanocytes. And this boosts, as I said, signal coordination. It regulates your inflammatory pathways. These are all things that we had never really considered before. That's not new in neuroscience. Perhaps it's a little bit off topic, but neuroscience only studied neurons for about 20 years. And we just kind of ignored the 5 other different types of cells in your brain, much to our dismay now. But this is, as I said, quite the common trend when we're looking at it. And if we're looking at, here specifically, our mechanisms of action, particularly it's important to note that these peptides, they either directly or indirectly, I prefer directly, particularly in the case of TRPV1, CB2, and MOR, they modulate receptor activity through receptor targeting. Now, that is somewhat different to neurotransmitter modulation because neurotransmitter modulation, it reduces overexpression or it increases the expression of a positive peptide. So for instance, as I keep on mentioning substance P, I'm really sorry that it's really not a more imaginative name. Substance P, it's your pain response chemical. It can reduce the overexpression of that, or it can increase, as I've mentioned earlier, our beta endorphin through the precursor talk. Now, something that is important to note, and I know I keep talking about how excited I am about neuroimmune crosstalk, our nerves influence our immune cells. In our cells, in our body, we have Langerhausen cells, we have mast cells. Through the manipulation of those cells, We can change the way the body reacts to external stresses. We can change the way, for instance, a mast cell reacts to an allergic response. Sure, we can't ameliorate, or we can't completely negate the allergic response, but we can ameliorate it. We can change the way that the loop itself is modulated and therefore reduce the inflammation of it. What I did not put into here was something that I found to be a little confusing. I shan't tell a lie. It is something called AEA. So that's anandamide, where it actively targets your lipid cells. So when we're looking at that, not only are we looking at changing the way that the structure of the cells are, but we're also looking at changing the way that the cells communicate with the nerves. So for every trigger, for every cell that gets activated, or for every vasodilation response, for instance, we are able to modulate and control this. I know that was very out of place, and I do apologize. As I said, I got quite excited, and now I have clicked the wrong link. There we go. Just to wrap up, or to go over some things before some questions, when you calm your skin, the important thing to note is that you calm the person inside it. That is the big thing. Your skin is a sensory organ. Your skin is talking. Neuroactive skincare essentially is learning how to listen and obviously to respond. We are no longer fixing the surface. I know I keep talking about the skin's own language, but we are. We are working with the skin's own language. So this in itself is really looking towards the future of precision skincare. And I say precision skincare because, as I said, we're not talking about exogenous moisturizers. We're talking about something that is specific, targeted, and has a very precise purpose. So with the right science, with the right ethics, we can create treatments that feel good, they work deeply, and they also connect the idea of skin health to wellness. Now, I wasn't going to touch on it, but when we're thinking of the idea of skin health and wellness, there are many branches that this goes on to. We can have the idea that I look good, I feel good. It's an oversimplification. It's not my best. But if I am itchy, and then all of a sudden I am not itchy, I feel a lot better. If I am flustered and hot and I feel flushed, and then all of a sudden I am not flustered and hot and I don't feel flushed, these things affect our emotional well-being. An important part of this to also recognize is the placebo and nocebo effect. It is important to realize that because this has an effect on our psychological well-being and because it has an effect on our emotional wellness, we also have to be aware that just because I like a product doesn't necessarily mean it works. All right. So it's why I keep on mentioning the right science and the right ethics. We must be incredibly, incredibly careful not to fall into the trap of simply saying, this works on this, therefore this. Science, unfortunately, is a lot like Gestalt psychology, where the whole is greater than the sum of its parts. And without these kind of evidence-based products, or without at least a good formulation and ethics, we fall prey to fast skincare, for lack of a better word. And that's not something that we would like. Now, I am not sure if there are any questions. If there are any questions, I would love to take them. I know that I didn't go in great detail about quite a few things, but please let me know and I will be happy to answer them.
Thanks, Donovan. I see that there's a whole lot of hand claps as well and hearts coming your way. So thank you. I think, yeah, definitely an hour is not, or not enough to unpack this whole the topic, I'm sure, and especially for people who are maybe on a less technical level, it could be it could be quite. It's interesting, but it's also a lot to understand. So we need more time. I'm just quickly looking here at the first question. So this is from Jacques. He's saying TRPV1, is this the receptor involved with analgesics, so like DPET, salicylates, and nicotinates? I think
Sorry.
do the analgesics just distract us from the pain, or is it actually helping with the healing?
Okay, so the analgesics, okay, let me break that down. The analgesics do distract us from the pain. Please remember, essentially, just imagine an analgesic as a key that fits a lock. It stops the transmission of signals through there, and because of that, that's the way that they work. I don't want to say that they directly influence healing. They don't directly influence healing. What they do is reduce inflammatory pathways, which reduces cytokine release. And the reduction of cytokine release reduces the negative inflammatory paths in that regard. In terms of TRPV1, yes, it is. Your TRPV1 is not only found in the skin, it's also found in a lot of smooth muscle. It is your primary receptor that deals with a lot of contraction. It is a calcium-gated channel. So in that regard, yes, that is true. But an analgesic itself doesn't speed up the healing process as the purpose of the analgesic. We refer to symptomatic treatment in order to treat the cause of something. So by reducing the inflammatory pathways, we can signal that the body needs to start repairing those pathways. I don't know if that answers your question, Holy.
Yeah, perfectly. Thanks, Donovan.
No problem. Thank you.
Sorry, I was just on mute. I had to change earphones. You can still hear me?
I can indeed.
I see you smiling,
Story of
Donovan, so you can. Ken just had a question here. Have you combined your research with hypnosis and EFT, so tapping, combining the neuroscience with working with the subconscious mind?
You're really not going to like what I'm going to say, and I'm really, really sorry about this. So in terms of hypnosis, hypnosis has its own place. The neuroscience of hypnosis, neuroscience does acknowledge that there are thoughts that are not on the surface. So they are not conscious thoughts. They are subconscious thoughts. They are unconscious thoughts. But when we're looking at the idea of hypnosis, hypnosis deals particularly with Freudian psychoanalytic theory, where you have deep suppressed desires or deep suppressed, oh my God, deep suppressed things. I beg your pardon, guys. Deep suppressed, or anything that is suppressed, and that is influencing your behavior. When we're looking at it from a neuroscience perspective, remember, we try not to use things like subconscious or unconscious. We try not to use constructs of ideas. So we prefer to look specifically at neural interactions. For example, Freudian psychology or hypnosis might say that your anxiety is because of having an overbearing mother. So you have a brick mother, so to speak. Whereas neuroscience would rather say that you have an overstimulation of neurons in your anterior cingulate gyrus and your striatum, and this is causing you to overreact to things. So I cannot say that I have combined my research. I know that there is a lot. Dr. Ryan Woods is currently trying to introduce psychoanalytic theory into neuroscience, because psychoanalytic theory or constructual abstract ideas are a little bit easier to understand than just a brain on a stick. But I can't say that personally I have.
Thank you, Donovan. I'm just going to jump to, I feel like a radio talk show host. So, next question from Shreya. What role do you think nanoparticles have in this emerging research as they are being incorporated in drug delivery systems and wound healing, etc.?
So I specifically left that out because I was like, oh my God, if I go into this, I'm never going to shut up. It is absolutely amazing. Nanoparticles are the future. Um, Honestly, when I say nanoparticles are the future, whether it be skincare, whether it be neuropeptides, whether it be specific drug interactions, the more that we can target or the more that we can get the active in, the better. So it is really, really going to be the pinnacle of it. Personally, I think that we should kind of just forget about everything and only focus on that because it is so effective, particularly when we're looking at like nanoparticles, as well as when we're looking at nano release of particles. It's a very, very effective way to do it. However, one must realize that the cost is massive. That is the biggest barrier to any sort of nanoparticle research. The cost is massive. But yes, I am a firm believer that that is the way forward in all science at the moment.
Right, thanks, Donovan. Then I have a question. So, what is the connection between neurotransmitters in our skin or in our bodies and our skin microbiome?
So essentially, the skin microbiome or the bacteria in the skin produce pseudo-neurotransmitters. In the same way that your bacteria in your gut produce pseudotransmitters, these pseudotransmitters obviously interact with a lot of the receptors, as I said, in the keratinocytes or in the melanocytes. And by keeping that skin biome healthy, how to explain this? If we imagine the release of beta endorphins, by keeping our skin microbiome healthy, what we can do is ensure that our skin is not overreactive. So the relationship between the two is a very symbiotic relationship, but with most bacteria in our body, they produce substances that act in a similar manner or that are similarly structured to neurotransmitters.
So,
I'm not
in
sure if that answers
essence,
it.
yeah, in a simple way for me to understand this is then keeping healthy skin microbiome obviously keeps my skin stress-free, and that's what we want. So then we don't have an immune response. Yeah, a healthier skin.
Yes, essentially that's what it is. As I said, if you draw the parallel between your gut microbiome and your health, we are suddenly becoming very aware that our gut microbiome has a huge influence because, as I said, they produce pseudo-neurotransmitters. And it's very, very intriguing when we're looking at the microbiome of the skin because it's not something that we've thought of before. My God, if you think about it, how harsh were we on our skin prior? I'm surprised like a lot of people even have a microbiome on their skin, to be quite frank with you. But it is that kind of interaction. So to oversimplify it, imagine that your skin's microbiome is kind of like the teacher at a play school, keeping everybody in control. So by keeping your teacher very happy, you make sure that it doesn't overreact.
Mm. Okay.
I don't know if that was a good analogy, but I'm trying.
Yes. Yeah. No, that's great. Thank you. It's a good way of explaining it to a non-technical person. So thank you so much, Donovan.
It's my pleasure.
I think, Bridget, I don't think that there are any more questions. I'm not sure if anybody.
Charis,
yes.
Charis you can just unmute your microphone if you like. And just between that, obviously, Will was saying very interesting. Thank you. Agree that the ethical considerations to avoid the slippery slope will become increasingly important in the industry as we move further into the space of linking neuroscience with skincare. So yeah, I mean, it's really on that new frontiers await. But Charis, you can unmute yourself.
Hi.
Hi.
Okay, great. You can hear me. Thanks very much. Very, very interesting presentation. I thoroughly enjoyed it. I've just got a couple of questions that going back to the beginning where you were talking about the stability of the neurons, right? have you considered encapsulation?
So encapsulation is a way that we do it, particularly. I probably got ahead of myself and didn't talk about it properly, so thank you asking. Encapsulation refers to our carrier systems. So encapsulation is a really, really big thing, but a lot of neuropeptides are quite large. So encapsulation in itself doesn't only work, but encapsulation is a very, very important part of it, specifically because of the fact that when we are looking at the way that they do get delivered, these kind of liposomes, because they are encapsulated within a lipid bilayer, obviously penetrate into the skin. But like I said, ideally, we would want to have kind of like a smart combination. So we would want to have those kind of carriers that obviously penetrate into the skin, but we would also want to make sure that we sort of create a layer over the skin so that we are protecting the skin whilst delivering that. So that is something that is being done. There's a lot of research into it. As I said, I am a firm believer in nanoparticles though, but it is being done like that, yes.
Okay, and then just another question. You mentioned the smart patch. Are the peptides, are the neuropeptides then stable in that smart patch?
So the neuropeptides are then stable in the smart patch. The thing is it's because it's something that's quite new. The smart patch technology is only being used in lab. And it's very, very difficult to just extrapolate from an in-lab environment to it. So I cannot answer that question wholly. The presupposition is that it is stable, and hence the targeted release, or at least the timed release. But I don't think we're quite there yet.
Okay. And then I'd just like to make a comment, because you mentioned how all these neuropeptides and neuroactives, how they improve your emotional wellness. So I'm studying NLP at the moment, and I just wanted to comment that your emotional wellness then leads to an improvement in what your conscious brain can actually deal with. So it actually leads to better thinking.
No, 100%, 100%. It's why I mentioned, like, I didn't want to call it the placebo or the nocebo effect. It is an important part. Look, there is not a single study that does not take in our perception of it. In fact, most studies with most of the clinical data on neuropeptides, perception is a large deal because it is true. Once you have a response, for instance, if you are smiling, you feel happier. It's a fact. That does lend itself to that. And I mean, I think that NLP in itself is quite an interesting field in that because it does give you a much greater understanding of how what you think is true, if that makes sense.
Absolutely. Absolutely. Yeah. Thanks, Donovan.
Thank you.
Talk.
Thank you, Donovan. This was super interesting. And like I said, I just think we don't have enough time to go through everything that you can obviously share with us. But yes, I thank you, Donovan, for your time today. It was really a pleasure to also have you in our COSCHEM talk today. And I am sure that if any of our members also want to reach out to you, perhaps there's maybe a topic that they would like to discuss with you, I'm sure you'll be more than willing to also connect with someone.
You just have to be aware that I have the potential to gush. So I'm very, very happy to do that. But please understand, you are signing up to there. But that is more than perfect.
No, thank you. Thank you so much, Donovan. And thanks everybody for also joining us. And I hope you all have a very good day today.
Thank
Thanks,
you, and
Marcel.
thanks,
Excellent.
Donovan.
Thank you,
Thank you.
Donovan.
Thanks so much,
Thank
Donovan. That was
you.
great.
Very interesting.
Hi. Thanks.
Bye bye.
Donovan, so can I just
Yes.
share your email if somebody has
Yes, of course.
query? Okay, so just have them pop-
Perfect.
But thank you. It's Bridget. I know there's lots of people on the platform, but it's me talking.
I recognize your voice. Don't worry, it's fine.
Yeah, perfect. Awesome. Guys, have a lovely day. Thank you.
Thank
Thanks,
you too,
guys.
Bridget. Thanks,
Bye.
Donovan.
Bye, everybody.
Bye-bye. Bye.